Right, it looks like we've got a good group of people joining. Welcome, everyone. I see we've got Morocco, we've got some folks from California. I think I saw Arkansas in there. Glad to have you here, Croatia. Welcome to our live coding session. Today's topic is next generation multi-tenant SaaS with Fauna and Algolia. So hopefully this is a topic of interest to you. This is an interactive session. We are live. We're ready to take your questions, ready to have some conversations. Just a little bit about myself first. My name is Chuck Meyer. I'm a senior developer advocate here at Algolia, and I host these sessions. We typically try and do it once a month aspirationally. We have different topics. We have different folks come in. Today, I'm joined by Zee Khoo. Zee is the head of solutions architecture at FaunaDB. Fauna is a company that knows a little bit about serving SaaS customers and brings some deep knowledge to the table here. And but before we get into the topic at hand, for folks that aren't familiar with Algolia for some reason, we provide a set of hosted APIs for developers. It empowers you to build search and recommendation experiences directly into your applications, whether they're mobile applications or web applications. And that's kind of the core of what we do. Zee, do you want to talk a little bit about Fauna and what Fauna brings to the table?
Yeah, hey, first of all, if you can't hear me, you let me know, right? We never know
Can
about
hear you
that.
loud and clear.
Cool. So yeah, you introduced Fauna initially as FaunaDB. That's actually our old name. We rebranded, so it's actually just
Oh,
no. But I actually like the old name because it says what we are. We're a database, so it's a modern operational database delivered as cloud API. So we're built on a really ground up new architecture that allows us to do some pretty fantastic things. So one of the main things there is we're deployed across multiple regions, but yet we are asset across all those regions with like almost zero penalty to your latency. Those are things that you actually can't see, but it's really important to mention that because what it does is it lets you start up using the database really easily. But as you scale, you really just don't change anything about your operation. It just scales and scales with you. And if you go to like different regions or want to have support customers across multiple regions, that's already done for you. But later on during the demo, you actually see other parts of, you get to see the parts of the database. And we're really hyper focused on developer experience and the productivity. So hopefully you get that when I show you the demo.
that's awesome. And I apologize for using your old name. I guess I'm showing my age and that I'm an old dog here. So
Don't worry, you get the right logo up though. So,
exactly. And just a little bit of housekeeping. So we do have chat open and you are more than welcome to chat with each other. Folks are saying where they're coming from. I see London out there. I see Nigeria. But if you do have a question for Zee or myself, we do ask you to use the Q&A tab that you'll also see there. It just makes it easier for us to kind of see those questions and kind of be able to answer them quickly. We'll try and answer them in real time if it makes sense, but we're also going to hold a little bit of time at the end of the session to answer any questions as well. But Zee, do you want to set the stage a little bit about kind of what we mean when we talk about next generation SaaS?
well, I mean, it's all about, I'm going to introduce maybe a term here called composable architectures.
Mm-hmm.
So the demo is when we get to the end of it, you'll see me using Fauna, which is a service. You'll see me using Auth0, another service, and that's for authentication, logging in your users. And then Algolia, we all know that that's a service. So in the old monolithic world, we kind of just built everything up from code and then we just threw that on a server. But next gen is about composable architectures. Don't rebuild things that are commodity type of technologies. And then on top of that all, I'm going to do this in a serverless framework. So it's a completely no serverless, no servers. We deploy everything as Lambdas. And then the API is handled by an API gateway. So I'm going to do this with AWS. That's kind of next gen. And then we make everything really complicated by making it a SaaS multi-tenant example.
Yeah,
Implication, yeah, you want to
everything
index.
gets more complicated with multiple tenants, that's for sure.
Yep.
Very cool. Very cool. Well, with that kind of set up, I'm going to stop sharing my slide deck and let's actually get into some coding.
Well, I'll take over.
Okay.
Oh, wait.
While you're getting yourself set up, I should mention that this is kind of a really interesting topic from the Algolia side, because people tend to think of Algolia as being more sort of web commerce, your web store, or your documentation, or something that's already publicly facing, and single tenant or sort of monolithic. So it tends to be kind of a situation where you're not really too worried about who has access to what. So I'm really excited to talk about this today, because I think, it's a very different use case for a SaaS or a multi-tenant customer. And there's some really cool stuff that you're going to be talking about today that I don't think gets a lot of visibility on the Algolia side too.
Yeah, for sure. Like even my own understanding, Algolia, mostly B2C type of use case.
Sure.
Though when I spoke with you guys before, you said that actually quite a big portion of your customers are actually doing SaaS apps. So
Mhm.
hopefully this will be really useful.
Hey,
And
before we jump into the technical side, we just had a kind of a 500-foot question from Ryan. Ryan just wanted a quick definition of multi-tenancy. What do we mean when we say multi-tenancy? It's a word that gets batted around a lot, but maybe we could just quickly define what it means in this context.
in context of let's say a B2B app, we're talking about SaaS here. So
Mhm.
think about a company that's delivering their software as in a SaaS model, right? So you're basically not deploying the software, you basically access it through the web app. Now, if this is B2B, so the customers of this SaaS company are other companies, and then they bring on their own set of end users, right? So because we're not deploying the application on the customer's data center or cloud, right? You kind of think of the SaaS as one big system that's partitioning the access to each of these customers. So if you go down to the database level there, we're really talking about how do you isolate the data for each of the SaaS customer, if that makes sense, right?
And yeah, I think that's a good explanation. So basically, you have built a software application. You need a database. You need search. You've decided to use Fauna and Algolia for those two functions. And now you have a bunch of customers, and each of them have their own data, and they're all going to be using these services through you. And they are your tenants, and your architecture is now a multi-tenant architecture.
Yep, multi-tenant architecture. That's exactly what it is. It's one system, but partitioning that data, right? Creating isolation. In the old days, well, I'll clarify this. In the old days, you could have just taken your monolith and then just redeployed it for every single customer.
Right.
And if you had 1,000 customers, you'd be managing 1,000 deployments. Obviously, that doesn't scale, but we're not talking about that.
So hopefully that answers your question, Ryan. And let's get in with that definition of multi-tenancy. Let's see what you built here.
Sure. So what I'm showing here, so this is not multi-tenant yet. Well, I'm going to build this out for you guys. So let's start with this really contrived example. This is single tenant, and then we're going to make it multi-tenant. Now we've got the database that's Fauna. It's only got two tables. We call them collection, the order and the product. And this thing's relational, right? So when you create an order, you got to pick right one or more products and associate that with the order. So it's kind of like has this relational model on it. This is a serverless system. So when you actually deploy this, if you go into AWS, that's why I'm going to do this. You only see really just two services being used: the API gateway, which routes all your API requests, and then behind each of those routes is a Lambda function. So I'm going to be coding up a couple of Lambda functions for you guys. And as a bonus, we're not going to do this through curl or postman or whatever. I actually built a single page app in Vue 3 so we can actually see some semblance of an application actually happening here. That's what I'm going to do. And then we're gonna actually wire up Algolia. and actually do some searches as well. And then we're going to take this and turn it into a multi-tenant system,
Awesome. Cool.
all
And
in the 30 minutes.
I love it. I love it. So we've got a Vue front end. We've got the guts of our business application as serverless functions. We've got our data stored in Fauna, and we've got our search through Algolia. I think this is a great architecture. We're getting some questions around serverless. I'm going to save those towards the end. Maybe we can talk a little bit about the nuances of serverless. It's just a design decision that we've made in this case. So we'll go forward with it for now, and maybe we can talk about reasoning later.
Yeah. I'm sure we'll have plenty of questions. Again, I'm trying to do this in 30 minutes, and we'll have plenty of time for Q&A.
Heck yeah.
The framework I'm using is serverless, but really, it's going to deploy API gateway and lambdas, but I'm doing it through a framework. I really like serverless. It's really clean, as long as you stay with JavaScript, because it won't support any other languages, I think. So
I've written some Python serverless functions as well. There's a couple languages you can use, but you're right. JavaScript tends to be the one that kind of goes in there.
This is the API. See, you start with the YAML file. This is essentially your API spec. And then I basically deploy this thing, and it just pumps it out there, right? Lambdas, and this entire spec here becomes API gateway. We're going to fill out 4 functions. I got a get products, basically list all the products. And then we got the create product part. And then we do the same for orders, create an order and list the orders. So that's what we're doing. So right now, let's set things up. Let's start with the database. Okay, so the AWS part is already set up. If you look at my config file here, I've got a profile set up. It's just pointing to my profile, got admin right, so I can deploy things to my AWS account. I've already set up an Algolia app, and we got the search keys and the search only keys here. But I need to set up Fauna for this. So let's show you Fauna again. If you guys are seeing this for the first time, some of you may already know Fauna, some of you not. I'm showing you the latest and greatest. This is in public beta right now. I want to show you the greatest stuff. I don't want to show you the old UI. This is how you create a database. And I get to choose which region I want this multi-region deployment in. If I pick the US, what I'm going to do, I'm going to get 3 replicas instantly. Now I've got a database in US West, I got a database in Ohio, I got a database in Virginia right now. And they're all going to be synchronized data in real time, and it's all ACID. There's no waiting for data to sync and all that, and data getting out of sync. I'm sitting here in California. So really, when I make database commands to my database, it goes to a router, global router, and it routes it to the database, the replica that's closest to me. So I'm just going to hit the California replica.
Well, that's cool. So you don't have to choose your region. It's figuring it out based on latency.
It's completely zero ops. It's already set up for scale. Even though I'm just doing a demo right now, this thing, once I'm done with it and I turn it loose, and all of a sudden, like, we get like 1,000, customers, it doesn't care, right? That's the whole mission behind Fauna. It's just to make your DevX as smooth as possible. Now I've got a database here, and I got to write some lambdas, and the lambdas are going to call the API, the Fauna API. So I need an API key. And there's some built-in roles. I'm just going to pick the big admin role. Oh. That hyphen.
Those pesky dashes, yeah.
Pesky, right? So I'm going to drop that. I'll make sure it's copied correctly. There we go.
If you can maybe +1 the interface on the Fauna side. The font's a little smaller than the other one. Just, I'm not sure if that'll increase the size or not. Yeah, there we go. Cool.
Thumbs up. So one more. I'm running out of space if I do that.
I got it. That's fine. Just keep, bigger is better. That's good.
Yeah. And then let's see, what else do I need set up? So I got my environment variables. These are going to be injected in as environment variables in my Lambda, just for demo purposes, right? In production, what I probably want to do is put the variables in the parameter store and encrypt that with a KMS. And then I'm going to use, I should use the Lambda or Lambda layer to decrypt those keys so that I can use them. But this is just a demo, so I'll inject them directly as environment variables in the Lambda, which is what this is doing, including the Algolia app ID and API keys, which is what I'm doing all here. And then let's start writing up. I'm going to fire up my app. So there it is. And then I'm going to show you a little network. So this is completely serverless. It's going to list products, actually. Well, it's not running. I'm going to go here. And we'll use the dev version of serverless. It's going to run. And then get product is actually going to be running. Yeah, this is the function. Where is it? Right here. Get products. Right here. And it's currently empty. Okay. It's just going to return some dummy response. So get products. Return some empty response right there. So let's code this up. I'm going to do this first, add product. So let's go to the Fauna dashboard to show you some syntax. I need a product table collection. And I need the order. Okay, let's see, create a couple of collections here. And then the syntax is product.create.
And just from a syntax perspective, a collection could be thought of as a table?
Yeah.
Okay.
It's used synonymously, right?
Yeah.
You know, in the NoSQL world, for some reason, they like to call it collection. So we use that term as well. This is the syntax, right? Field 1, and then put the value. Field 2, put the value in there. So that's what the syntax.
Double check. Okay, got it. Yeah.
Yeah. For the products, I already have a. Oh, by the way, I keep looking up there because that's where my answers are. I got two screens going. You guys wondering?
That's okay. We're all looking at your code anyway.
Right. So let's save this. That's nothing's going to happen here. But this is the shape of the. Why isn't? Oh. Why is it coming out? Because I don't have anything in there. Well, okay, that's fine. I want to do product create. It's got SKU. It got a name. You saw the form. The form. Got a description. Price. Quantity. The quantity means stock. You know how much I have in stock, and then I got a couple of things in here. Back ordered limit. That's basically telling me if I reach that limit, I basically want to set that flag to true. So that's the demo, and so that's the syntax. Okay, now we actually see that get created. What I want to do is just copy this. So I like to talk about or focus about the DevX because I want to show you how easy it is to transfer that query into the code. So first I need to import Fauna. It's already installed. and then I want to get the key. That's from the M variable. And then we're going to instantiate. Let's go back in here. Try hatch. Okay, what do I want to do here? Code. Doesn't like it. Yeah. Oh, of course.
go.
Responsive, right? Response. Body. So in my hive here, I want to instantiate a Fauna client. Oops. Okay. And then I want to put my query in here. FQL stands for Fauna Query Language. And then I'm going to copy the rest. So I send my query through the client. I don't want to, all right, that's for later. Send my query through the client. It's going to return a response. The response has some data in it, and then I'm going to stringify that, and that should do it. So back to this query, copy this guy because we know it worked. Paste it in there, and then I want to basically do all this string interpolation. Let me get that. I don't do a ton of live coding, so I don't actually know how fast and slow I'm doing this.
Well, worst case, we are coming up. We're at 9:25 now, so
I think it's still a good pace.
I think you're doing fine. Worst case, we can always drop a couple blocks in, full cloth. But I'm enjoying this so far. I haven't used Fauna as much, but I will say that this looks very familiar, right? Like I feel like as you're using sort of these composable tools, you're going to see these patterns of instantiating a client and then sort of, basically CRUD that maps to REST very well, right? You're going to have a create operations, you're going to have modify operations. So this looks very familiar to me.
Familiar, right? You're grokking it. It's not like I'm using some ORM or, I'm writing SQL or it's some weird kind of language. Hopefully all this looks very familiar. The whole idea is to get you learning something new really quickly. So put a lot of thought into this. So I think this is it. This is done. This should be it. This should work. I think so. So should we give it a try?
I would love to see it. Let's get a product in there.
Okay. It doesn't hot reload either. SLS. Bummer. But okay, now it's running.
Is SLS open source? I'm trying to remember where it came from.
It's open source. It's open source.
Okay.
So
we were having a little chat in chat. We were talking a little bit about SAM versus SLS, and I wasn't sure if it was open source.
Add product. So how about Nintendo Wii?
That's cool. I still miss mine.
$150. I think I have heard these. Okay. So remember, we haven't implemented the list products yet. Yeah.
Oh, so we can create them, but we can't.
Why did my network stop? Working. But anyways, let's see what's. Oh, there it is.
All right.
It is. Okay. Okay,
Awesome.
That's good. Now let's do get products. So I want to move a little faster because I only 12 minutes left, but
let's
We
go
got
ahead and yeah, maybe if we can drop a little code in here and then we can
Let's
just walk
drop
through it.
some code in there because we have to do the Algolia thing too, right? Just gonna drop code in here. Boom.
Yeah, so we definitely have some folks that are very interested in sort of the pattern for keeping these things in sync. So definitely,
Right.
let's get to it.
So that's the query, product, all. And then these curly brackets here, if you know GraphQL, this will be familiar. This is GraphQL projection. So I'm projecting these. So I want the response in my query to return this stuff. Because why? Because later on we want the response so that we can go send it to Algolia to index it, right? Everything's optional. I could just return an ID if I wanted to, or a couple of fields, but I want to index all these fields, so I'm going to return it so that we can send it to Algolia. Now let's see if. Oh wait. No, that. This is for later. Let me double check the code.
Oh yeah,
Got the
spoilers, right?
plan. Everything looks right. Okay, save.
Now, if you listed a field there that didn't actually exist in a record, does Fauna just return like a null value for that field, or?
I wonder.
I don't want to derail us. I was just curious. So.
I wonder. So, okay, and let's do a
foo.
fake foo.
Yeah. Yep. So
No.
you just get a null back. That's cool. Okay. Just curious.
Okay, so this thing's here. Let's see if the app is doing a thing.
Look at that.
Okay, so we can move really fast here. Let's do Algolia. Let's code Algolia.
So
there's a search. There's a search right here. It doesn't do anything yet because we don't have any data in Algolia. But now we're going to feed Algolia. So, okay, we're going to import Algolia. Don't forget to do that, and then I think you guys should be familiar with this, right? You instance the Algolia client, and then initiate an index. What I'm doing, and then so I got that index. I'm just gonna save object. So
I think one important thing to point out is that we're using an Algolia client. We're going to need a key with appropriate permissions to be able to write, right? Because we're programmatically writing into our index on this one. So
I am using. Tell me if I'm doing this wrong. I'm using the key, the admin key here for this index.
So admin key will have full rights for this. You could potentially scope that down a little further if you wanted, but admin key is the right way to go, not our search key for this. Just something I'm pointing out for folks.
Yep. And I'm not sure if you guys remember when I created this product, I used the create command. I already cleared it. It did return all the data to me again. I want that so that I can, index it. So the index is there. We just go save object.
And then every time you do a create object within your database, we are immediately doing a save object into the search index in the same sort of breath.
Yep. Yep. And then I'll go a little slower here so that we can see what we're doing on the search side. So the search is implemented using the API is the same API as get products, but we pass in the query string parameter. So, search equals a term. So that's how I'm doing that, designing an API. So we're gonna find that search term here. And then this is the part. So we're going to oh, I don't want to do this. There. Generate a search key, right? So this is different now. We generate a secure key, and we use the Algolia search only key for that. And I'm going to instance a brand new client for this.
Yep. Okay, cool. So the back end, remember when we were writing records, we're using our admin key to write records into the index. Now we're in the front end. And so you could use that search only key that we generate for you. But what we're doing here, what he's doing instead, is he's using an API that allows you to generate ephemeral keys that can be used in the front end. And there's a lot of interesting things you can do when you generate those ephemeral keys. Spoiler alert. But you can see like
Alert.
here, yeah. So here you can see one of those things is you can make them ephemeral. So this key is only valid for, was it 5 minutes?
5 seconds.
Wow. So
I
you're
mean,
really ephemeral here
we don't need it because we generate the key every time we hit this
every time.
API.
Mm.
Yeah. I mean, 1 second. We know Algolia is super fast. So we have to get the new index, and then we can pass that search term into it, and then the results are going to come back. It's going to have some bunch of metadata in it, but we just want the hits field out of that, right? And then we populate our response body and then do the callback. So this should all be wired up just like that. If we return here, so if I find a query string, we return, we skip the database part. So let's do this. Wait for it to come up. Let's add a couple of products because the first two weren't indexed. So I want to play stage 5.
So again, and the reason they weren't indexed is the way that we're keeping these in sync is programmatically within the application itself. So this application, so because we didn't have the code to write to the index, the index has no idea that those two products were ever added.
Yep.
So that obviously there are interesting things that folks do with, webhooks and stuff like that. But for this case, we're just kind of doing a simple client side, one add on via an API, another add via an API.
Anyone know how much these things cost? $1,000.
What's the going rate for a Quest Pro, everyone on chat? 1,500.
Wow, really?
Yeah.
It actually.
Well, so this shop's a deal. Uh-oh.
It threw an error. Why? Why did that do that?
Which side was it?
I mean, I wasn't expecting this.
Well, that's live coding for you, right?
Yeah. Let's do that again.
Yeah, live coding becomes live debugging. Exactly, Ryan.
Why did it do that? It's $1,500. I don't know why it did that. Let's check out the next. Let's see the next. Let's take a look. Maybe how do you get there? Refresh button on there.
So you're in here. Okay. So are you sure you're in the right app? Yeah, this says there's no indices yet.
Did I not create an app? So my app is.
You should have your app ID. Let's double check that. Okay, so go back over to your dashboard. Go see where it says applications, that drop down there at the top. And then if you click on that, it should see, that looks like it matches up.
That's the app.
And then if you click search, you should see your indices.
Where's my index?
Just make sure.
What did I do wrong?
Yeah, I'm trying to think myself.
The keys haven't changed, right? So
yeah, let me see where you instantiate your Algolia client. Let's see, so index
ID and the key
Algolia client, and then you're knitting your index. The index name should be products. All of that looks right to me.
I should have.
Let me see your save object. Yep.
I don't have to await this. It didn't catch any errors either, right? When I was saving it. Well, maybe that's why it.
So, so will init index create index? Yeah. So it's init index is idempotent, and you actually don't even need to call init index. The first save object should actually create an index as well. The way the API is set up. So that looks right. I'm trying to figure out why it's going wrong on you. So you're getting these in your. Is there any chance you didn't publish the latest version of the code up to the Lambda?
Oh, that's see, it caught an error. And see, so it's crashing definitely because this. I didn't catch it though. What do you think is wrong? What did it do? What are we doing wrong here?
Yeah. So someone at Ryan's asking, did your Lambda init code run again, get redeployed?
Again. Hmm,
That's got a 200.
but it did crash.
On your get products.
Oh, it won't catch. It's definitely coming here, right? Coming from here. Coming from there. But won't catch it. What is wrong?
I'm looking. Let me see. So your index name is products. That's good. You've got Algolia app ID and Algolia API key, and you're grabbing those. You're injecting those directly. Where are those assigned? They're assigned a little further up, or they're assigned outside of this.
It's evolving on me.
Does instantiating the Algolia client need to happen inside the function handler? Where?
No,
Yeah, that's a good question. So you're doing you're instantiating the client
outside.
at the top outside the handler.
Yeah, I mean, this thing was working fine. Why do things always happen when it's live?
It's the demo. It's the demo effect. You can't help it. Let's see. So what could we do to get this working again?
It doesn't help that we can't see the errors, right?
It really doesn't.
Let's do it again. Okay.
So I know for SAM, there's the service application model. There's like a SAM logs region, and it'll retrieve the CloudWatch logs from the Lambda. Is there an equivalent for SLS?
Yeah, well, it's not deployed. I'm running this locally. So
Oh, got it. Okay.
yeah, the output being tailed from the terminal.
Okay.
So man, what's that? $20. Um,
We'll give it one more try here. We'll see if we can get it. And if not, maybe we can dig into the multi-tenant code just to kind of at least show it.
there. Ha!
The object ID.
Ah! Guys.
Oh,
Oh
I should have
man.
caught that.
Ah,
Okay.
okay.
Yeah. So you either have to for Algolia newbies, for Algolia folks like myself, I should
I
have caught this.
completely
But for
forgot to
Algolia
do
newbies,
that.
you have to have a unique ID for every record. Usually, you inject that in based on like an object ID you're using for
Okay.
your source of truth.
I
It
want to
can generate object IDs too for you, but that's why it's rejecting this. Oh my goodness.
right. So we
So
we
can we
want
make the SKU? Can we just reuse the SKU as the object ID as well?
no. See, that's what I wanted to do. You saw that?
Oh, okay.
I wanted to project my data back. I was just talking about that. I wanted to project it back, but I didn't.
for GraphQL?
And our internal ID is ID, but the API wants object ID, so we alias this.
Mm.
Ah,
Haha. But you solved it. That's great. And now we got 2 minutes
well,
to get through the rest, but that's okay. We'll maybe what we'll do is while you're coding, we can answer some questions too.
yeah,
Because I really do want to show the multi-tenant version of this as well. I think it's
yeah.
pretty cool.
Okay. That should do it. Okay. Now it's in there. Oh man, how much time did we waste there? 5 minutes? There's the
It's
index,
okay. It was a learning experience. So there
right?
we go. So yeah, and you can see on that first saved object, once it worked, it goes ahead and it creates the index for you as well.
So we can go ahead and do multi-tenancy because we don't have time to go and do the order service.
That's
So
fine. We'll go through products,
yeah,
and
because you
maybe we'll
gotta
do a
get the,
part 2 later.
no, I wanted to come back to part two. So
Yeah,
let's do multi-tenancy. For that, I want to switch to this. There,
sure. And I can get through this really quickly. So basically, I was going through and kind of looking at some of the different mechanisms for doing multi-tenancy on the Algolia side. And so Algolia at the top level, you saw we have this application ID. That is a very, very firm boundary. You could theoretically build an application per user. The problem is there's no programmatic way to do that. And they're all sort of maintained individually. They have their own building, et cetera. So that would really only be a use case for if you really needed like a really hard boundary around your customers. There's the opportunity to do it at an index level. As you could see, index can be created programmatically. We just did it. But the challenge with that is that there's a hard limit of 1,000 indices per app. So if you're a smaller company, you have less than 1,000 customers, that could be a good solution. But obviously for folks that are ambitious and want to get bigger, it's not going to work too well. So the third way of doing isolation is using these secure keys. Like Z has already using, he's already building these keys and generating them to be ephemeral, but there are some additional fields you can do that allow you to do data level or essentially the equivalent of row level isolation of records. And I'm not going to talk too much about it because I think Z is about to show us it, right?
yep, I'm going to show it, and that's on the Algolia side. So
This is
on the
all
fauna,
Algolia, yeah.
on the fauna side, we're going to do something pretty neat here. If you guys built multi-tenant SaaS before, you're thinking, well, I got to partition my data in the same collection. No, we're not going to do that. We in fauna, we have a really neat construct here of parent-child databases. So what I'm going to do with fauna is I'm going to create one database per tenant. So and each database has the same schema of product and order collection. You saw when I create that database, it's instant, right? That's why I can do it because it's purely logical. We're not spinning up memory or anything like that. It's purely logical. So a parent database can have 1,000,000 child databases, no problem at all. And the way we do this is, so we got that API key. To access a child database, I just append the name of the child database to that API key, right? And so the code modification here is really, really simple to do that. So first, I need to set up my parent-child database structure. So we set up the parent first, and then we can just do, database create. What do I want to call this? Tenant A. Let's refresh a little bit. Oh, there. Tenant A, tenant B. That's all I want to do. Got two databases. And then of course I need my order and database. Order. Oops, there's gonna be a little bit of noise. Hope you guys don't mind. So I've got my two tenants set up, right? We just need the two collections in there. I'll let you do the coding here. So, I'll show you the slide. So I've set up everything here. We need Auth0 in here. I need to log in now. And then I have two users. One user belongs to tenant A, one user belongs to tenant B. Now, when you log in with Auth0, it gives me a JWT. That JWT contains the tenant ID in there. So either tenant A or tenant B. We're going to set up a Lambda authorizer. It's going to validate that JWT from 0. And during validation, it's just going to unpack that JWT and find that tenant ID claim in there. And then it's going to inject that tenant ID into the context of the Lambda request. So the code looks like this. In the authorizer, this is the Lambda authorizer at my gateway. It's going to verify the JWT. There's a custom claim in here called the tenant ID. You see that? Right? And then I'm populating the context of my authorization policy. That's all AWS stuff. So once this is populated, this thing called tenant ID, I can access it in my Lambda. So this is how you do it. Do more copy and paste. It's in the event request context authorizer, the Lambda tenant ID. Now I have the tenant ID. I want to basically append it to my API key, right? Like that, and give it a role. Just like that. That's all I have to do, guys. That's all we have to do.
Now we're isolated, and each of these is going to its individual database. Very cool.
That's it. And then, so for the, how do we do this? For the
search index
Algolia piece, I'm going to append the tenant ID to the object that I index. I'm going to append the tenant ID to that, right? And then we go configure in Algolia. Oops. A facet. Oh, actually, I haven't. Will it come out?
I think you're gonna have to have one. Yeah, there it is.
Don't let me do it. So we say filter only. This is from the docs. I'm not sure what all the other, but the docs say do it like this. So I'm doing it like this. So now we have.
So the concept there is there, when you do faceting, it's either a facet that you're going to surface to the end user so that they can use it for searching. This is going to be an internal one that we're only using to filter records. That's
got it.
Yeah.
Got it, right? So what we got here. So when we send this to the index, we also give it the tenant ID to the index so that when we search, we can just, right, isolate to that tenant ID. So this is how we do it. You get the tenant ID again from the context for get products, get the tenant ID. Don't forget to do this. Oh,
While you're doing that, so someone was asking, why would we want an Algolia index as opposed to just querying against Fauna directly every time? And if you don't mind, I'll take a stab at that one. Keep in mind that, an index and a database are very different storage mechanisms with very different use cases. One thing, and I don't think we're going to get to it today, that Zee was dying to show you is how you can do joins, how you can, grab data from multiple tables, do all the things that you're used to doing with SQL in a database. Algolia is a hashed index. and it is just designed to be lightning fast at returning results for your user, and providing them with an easy way of sort of filtering down on those records. So we're doing kind of a toy case where Z is typing something and then hitting search. In a real world example, it would be type as you go search, where every keystroke brings back results. We're ranking those results on the fly based on criteria that you've provided. We're filtering those results based on refinements that the user is selecting. It's a very different use case. The one difference that we're doing and we're showing here is you can do that and also limit the records that are returned based on this tenant information. So hopefully I did a good job of saying that. I don't know if there's anything you want to add, Z.
Yeah, and I mean, plus the indexes in Fauna are designed for really fast lookup by term. So they're kind of like exact searches. Algolia gives you that sense of fuzzy search. Like I could index like really complex objects so I can join together. I wanted to show you this, but I can't. Like in my order has a shopping cart in it and it references all these products. So my order would have like, I bought a Wii and a PlayStation, okay? And then I go index that order and I go search against the order index and I say Wii. But Wii is a product, right? It's not the order. But Algolia is going to return that because I can essentially index anything I want in that object.
And you bring up a good point about Algolia has baked in typo tolerance and word proximity awareness and all sorts of things that you would expect from an interactive user search that aren't necessarily pieces that you would want in a database. Typo tolerance isn't necessarily something you need in your SQL query or your database query. So that's sort of the differentiation there. But let's get back to what you've been working on with your code here.
So while we were talking, now this is the unfortunate thing about the serverless framework. In the local version, it won't let me run the authorizer on the Lambda authorizer. But we actually got to deploy this. I don't even know if we have time, but I want to just put this in here and deploy it. And while it's deploying, we can actually talk about the code I just wrote. Yeah, let's deploy that. So now, once again, in the get products, we get the tenant ID. Same thing here with Fauna. We just append the tenant ID, which is a database name, to the key. And this is all we modify on the Algolia part. We add the filter option in here, and we say tenant ID equals blah blah blah. Right. So so how many lines did we add to turn this into multi-tenant, guys? It is now if I didn't make any mistakes, it should be multi-tenant. We didn't add a ton to the core code. Now we had to add the authorizer and all that. We had to plug in auth0 and set that up so that it generated a JWT with a tenant ID and all that.
I would argue that's table stakes for a multi-tenant infrastructure, though.
Table stakes, right? But our core code, a few lines, we are now multi-tenant. And it's uploading. We have 5 minutes. We don't have to show the demo. Maybe part 2.
So I think the important thing to take away there from the Algolia side is that filter that Z just added, that is baked into the key that you surface on your front end. There is no way for that user to get around that filter. So the keys that you are surfacing on the front end, and someone was asking, I'm sorry, I don't have your name, but someone was asking, like, do you have to do all your searches on the back end? No, that's the whole point of this, is that you're generating these ephemeral keys that can get surfaced in the front end and used for search that are hard-coded to the individual. Now, the important thing to remember here is because the filter is baked into the key, this now means that that search key that historically for front-end interfaces you would just kind of throw everywhere, that's now a secret, because if someone has access to that search key, it doesn't have the filter baked in, they can look at anything. So you no longer surface that on the front end, but you can use these ephemeral keys anywhere you want, your mobile application, your web application, and those users will always be limited to just the records that are tied to their tenant.
Yep. I think this is very fast. That's a good point, right? Like generating this ephemeral key was actually very fast, and I'm actually doing it every time we hit the API. But you could have squeeze like a couple of milliseconds off your performance by generating the ephemeral key on the client side and reusing that, so we don't have to do it on the server side, right? Like if that was a factor, um, we have to do that. And then there are a couple of other things to note also, like the search result could have just returned my data and then I display it in the app. I could display the data in the app from, well, it's not running, but that all that data came back, or it could return me the object ID, and I use the object ID to make a database search to return even more data from the database that, that if I didn't save that data in Algolia. So we could do a combination of.
So for better or worse, we have about 2 minutes left, and I think like 14 questions. It's amazing. You all have such good questions. Let's see if we can knock a few of these out quickly. From Mitch, is there a concept of inheritance from the parent DB on the Fauna side?
We're actually working on that. So you saw how I manage the schema manually. I have to go into each child DB and basically add those two collections. So we're working on the inheritance part of it. We'll see how that basically shapes out. But in absence of that, there's actually tooling to basically manage your schema as code. That's probably where we're headed. So if you're basically, your code is your master schema, and then when you create or update databases, you apply that using tooling, you apply the changes all across every single child database.
And Julie's saying it's okay for us to run a little bit over to answer some questions, but I do want to remind folks that we did record this session. It will be up on the Algolia YouTube channel tomorrow, and I think we're going to give it over to the Fauna folks, so it'll be over on their channel as well in the near future. So there will be a recording. Another question here, someone was asking about, does this mean we have to proxy all of our search requests through the backend? Absolutely not. I think we answered that already. The whole point of the ephemeral keys is you can continue to do these searches on the front end without having to worry about users getting access to other people's data there. And let's see, here's another one is, for Fauna to Algolia, does either company put out a tool to import previous Fauna records into Algolia? On the Algolia side, we have the ability to do batch import from a CSV or a JSON file. I don't know if Fauna has the ability to do an export to get in that record shape.
Yeah, so you saw we just write queries, right? And then you can shape the queries any way you want using projection. So the idea here is that you write your script and just pump it out. But then, like we did an integration with something called Airbyte, which can also pump it out into a JSON file if you choose that as a destination. And a couple of tools to do that, a couple of ways to skin that cat, really. But right, you want to get in the format that you want, and the query language is a perfect tool for that. And you spit it on write a script, spit it out into some JSON lines.
Yep. So there's not a pre-baked tool, but these are all API first services. We all speak JSON. There are easy ways to export JSON from Fauna and then import that into Algolia, and vice versa for some reason you needed to. So that's good. I think the most important question for any dev what about free tiers? So I know Algolia, we have our build tier, which is free. It's feature complete and has 1 million records. What's Fauna got?
Yeah, we got a free dev tier with pretty generous limits on it. So if you sign up, that's automatically a free dev tier. And then you use it and you hit the limit, it won't stop you. Even if you hit the limit, we'll just send you a reminder to basically upgrade or basically, just throttle down.
Cool. And then Aaron was asking about real-time sync. Is there something available now? Can they use Airbyte for real-time sync?
Airbyte is a near real-time sync, right? I believe Airbyte, you can pick Algolia as a destination. I'm not quite certain. I can't remember. Near real time because Airbyte works on like a cron. And then, well, we're working on things to make the sync from a Fauna query to any external system like real time. Basically, you can imagine what that is. Like other databases have that. We're working on the same thing, but again, making it more dev friendly experience. So
another topic for the 2.0 version of this conversation. Awesome. Are there any downsides to having a Fauna DB per tenant?
No, no. So, see, like I mentioned before, the database creation you saw that was instant because we weren't creating a database. It's just a shell, right? You have your Fauna account, and it's a container for databases and account, and each database is a container for collections in there. It's all fully logical. There's no reason why you shouldn't have a million. Okay, we're not going to get a million tenants, right? 100,000
Let's be
data cloud
ambitious.
databases. That's actually fine. The
Mhm.
size of a database is the total number of bytes that's stored in it. That's how we see it.
Cool. Excellent. Lots of people are asking about the sync, so it sounds like there's a lot of appetite for
Oh,
better
good.
mechanisms for syncing. So we'll keep thinking and iterating on that. We both have the ear of our dev team, so we will definitely mention that back up. One thing that Aaron did mention was looking for something out of the box like CDC. I don't think there's anything that's kind of equivalent to that, but the AirSync might be kind of your best next bet.
Airbyte is the right
Airbyte.
now the
Mhm.
solution, right? It's used in conjunction with DBT. It's not fully real time. We're gonna work on things like a Kafka plugin, a connector for Kafka to
Mm,
make it more real time. So these are requirements that we heard from the field. We're actively working on these.
cool. Um, Can MG ask, can we talk about some of the clever things that Algolia does behind the scenes from a latency perspective? I wish we had time. We'll have to save that for another day, but yeah, we are obsessed with latency. As you know, you've seen some of that kind of play out here, but maybe we'll dig in on that on another session. Um, Fauna regional isolation. Can you talk a little bit about regional isolation for fauna?
Yeah, sure. Remember when I did this? So there are a couple of options you have. So when I did the US, there was 3 replicas in the US. It covers coast to coast. It's the same thing happens when you pick Europe. So it'll be 3 replicas in EU countries, coast to border to border, and that satisfies GDPR requirements. Or there's classic, which actually goes from US all the way to Eastern Europe. It's like there's a classic one, and actually we should have called it global as it spans. If you don't care about the isolation, the geo isolation, you can pick classic, which is really good for global latency.
Cool. Excellent. And then on the Algolia side, like I said, you tend to pick your region for your application. So data isolation via geography would be at the application level. And then we do have a concept of what we call a distributed search network. So if you have a larger, more complex enterprisey setup, there are other things that we can do to make sure that you're aggregating across regions appropriately. But there are definitely kind of similar tools there. And it does a very similar sort of nearest location identification. Again, we'll save it for another day though to talk about that. Just a couple questions left. John wanted to know, is there any sort of sanitization on the client side with putting those queries, or does deserial, I'm sorry, I'm not reading this very well. Do we need any sort of sanitization on client side while putting out those queries, or does deserialization at Fauna and take care of that?
What? Yeah, what do you mean by
Not
sanitization?
sure. Yeah, sorry, John. Yeah, I'm not quite following it either.
So maybe this answers your question. The string interpolation basically is a pattern that's commonly used when you send database requests over the wire to prevent things like injection, right? Like
Mm,
injection attack. So maybe it's talking about that. Not sure what else. Other than that, it goes over the wire using TLS. It could be. I should mention also we save the data encrypted as well. Other serverless databases actually don't do that, so we also encrypt at rest.
got
So
it. Got it.
maybe talking about that. Yeah.
Yep. You got a shout out for the Kafka plugin. Aaron's very excited about that in the chat, by the way. Um, and then the last question, and was kind of, I think, the first question, which was, does serverless mean less cost as we create microservices? Isn't it slower than a server? It's a design choice, I would say. You're thinking in terms of scalability when you're doing serverless. You're not necessarily thinking in terms of cost. But you're thinking about not having to maintain the servers. You're thinking about being able to scale horizontally very quickly. If all of a sudden catch on, you have your chat GPT moment. I don't, anything else you want to add, Z, about doing it serverless?
Yeah, right, but in terms of cost, yeah, obviously you don't hire anyone to maintain all that all that infrastructure, because there is no maintenance of the infrastructure, right? It just functions. It just functions, right? Your function sets your function, deploy, scales automatically. Obviously, that could mean that, you know, if you hit a chat GPT moment, your cost can spike because you have more usage. Sometimes you want that, but sometimes you don't, and then you kind of set limits for that, right? You can set throttling, you can set alerts for that, and you can manually intervene. There's quite a few strategies to actually mitigate that, but you need to be aware of it ahead of time, because it's going to be a new type of operating, a type of application in a new paradigm, so you got to be aware of it. And some people just aren't, but I say you be prepared for it, and then you should be fine.
Yeah, I would argue you would use a serverless architecture for the same reason you're using a managed service like Fauna or Algolia, right? You don't want to have to do that maintenance yourself. You don't have to do the tuning. Um, you're willing to pay that sort of management cost to not have to worry about those pieces of it, and to sort of let each piece sort of be the best that it can be. That's kind of what you're doing in Lambda 2. You're just taking your own code, you're breaking it up, and you're letting each piece of the code sort of be the best version of itself. Maybe that's a little trite, but that's sort of how I picture it. We are over time. I think we got to all the questions. I appreciate everyone for being so active and engaged. I appreciate Zee, you coming on, and obviously folks were very interested in what you're doing. I know we kind of rushed a little bit at the end, but is this code going to be available somewhere where people can maybe take a peek at it?
I'm going to clean it up and put the solution up in our GitHub, and then we'll find a way to basically announce that information to the attendees today.
Very cool. What's your, can they look up your GitHub user to maybe find the repo or find?
Look up under Fauna-Labs.
Fauna Labs. Okay, great. Well, thank you everyone for being so engaged. We'll be back. I think we're skipping June because we've got our big Algolia DevCon. Hopefully folks are planning on attending that in June, but we'll be back in July with, I think it's going to be Stream.io, but don't hold me to it. But thanks again, Zee. Anything else that you would do as a call to action for folks from your side?
I don't know. Great questions. Really, call to actions obvious. And give us a try. This is the best database that you can use if you're going serverless. Like I honestly believe it is. I've been doing this for a long time. And looked at a whole bunch of choices, got really attracted upon, and that's why I'm working here. So
Awesome. Well, thanks again. And to everyone that's out there, we'll see you at DevCon. Bye.